Hi science students, welcome back. Today we're going to deconstruct AKS 8B. Let's go ahead and read the AKS. It says to construct an explanation based on experimental evidence to support the claims presented in Newton's 3 laws of motion. So let's identify what our key vocabulary is throughout this standard. First, we're going to mark construct an explanation. Next, we're going to mark experimental evidence. And lastly, we're going to mark Newton's 3 laws of motion. So these are going to be our 3 key components as we're talking about this AKS. So we have talked about constructing an explanation before, and I'm going to use my blue pen to talk about my science and engineering practice of this constructing an explanation. So I'm going to draw a little arrow up here with my blue pen. Construct an explanation as a scientist, we're going to use the CER method to explain your understanding and support that claim with evidence. This standard actually tells you the kind of evidence that they want you to use, but in order to construct that explanation, I need to be able to make a clear CER claim, evidence, reasoning statement, and be able to support that with the kind of evidence that they tell me I have to use. So let's move on to this experimental evidence. So our experimental evidence could include relationships between several different factors. So I'm going to use my red pen for this, for part of it. And I'm going to draw a big arrow up to the top here. And I'm going to write, could include relationships between, I'm going to put a little colon. I'm going to zoom this in for you just a little bit so it's easier to see. A little less crooked. Okay. I'm going to put a little line underneath just so that it's easy to tell this is my header. So my first factor that could be used as part of my experimental evidence would be looking at the force. And so force is going to be action that can change the motion of an object. These forces can be balanced or unbalanced, and we will talk about this as we go forward, talking about force and motion. But for now, we're going to leave this definition the way it is. Our second factor that we could continue to consider a relationship to show that evidence with would be the mass of the object. And the mass is going to be the amount of matter in the object. How much stuff is the object really made of? Our next factor is going to be velocity. And velocity is going to be the rate at which an object changes direction, or changes its position, So velocity is going to be that rate that the object is changing its position from one place to another. Our last factor is going to be very similar to velocity. and it's going to be called acceleration. And acceleration is going to be like velocity, but includes magnitude, which we'll get into as we talk more about force and motion, and it includes direction. If you need to pause the video to write any of this down, please do so. If not, we're going to go ahead and move on. Lastly, we're going to talk about that last key vocabulary that we marked, Newton's 3 laws of motion. And there are going to be 3, so I'm going to draw 3 little arrows and just try to make 3 sections here. So with my pink pen, I'm going to draw an arrow this way first, and I'm going to write the first law. And the first law is often thought of as the law of inertia. So I'm going to write that, inertia. And just to kind of create a little header box, I'm going to just kind of draw a box around like this. And the first law of motion states that an object at rest is going to stay at rest. Or an object in motion will stay in motion until a force acts upon it. So some kind of force will have to act upon the object in order for it to stop moving or in order for it to begin moving, depending on what the object is doing at the beginning. Our second law of motion, I'll put in the middle and I'll draw a little arrow like this. Our second law in our title box, we're going to write a formula. F equals M times A, like that. And then I'm going to draw another little box around to make that my header. And our second law of motion is going to be that force equals mass times acceleration. Our third law of motion, we'll draw over here. Our third law has to do with equal and opposite pairs. So that's what we're going to write. Equal and opposite pairs. And then we'll make our little header box around it, like that. So our third law states that for every action, there is an equal and opposite reaction. So I'm going to put the whole anchor chart back on screen. If you need to pause the video for any part of this, please do so. If not, have a really great day. Bye-bye.